Jai Hind everyone. I am Achintya Pandey, Assistant Professor in Department of IT at Ajay Kumar Garg Engineering College. Today I will explore the topic UML diagrams in object-oriented system design. In my last video, I have discussed the features of object-oriented programming system, in which we have discussed more about what are object, what are classes, encapsulation, inheritance, polymorphism, data hiding, and all that. So while we develop the software using object-oriented approach or system design, we required to prepare a model before developing. So just to model the software system, how you model, and there are even open source software. By that you can model the software, the design of software, everything related to the development of software. So while modeling, we require some representation, how we can represent in form of diagram. So this UML diagram consists all those diagram which is required to model the software system. Okay, so this is about. So in this I will explore the UML diagram. So first, what is UML? So UML is UML stands for Unified Modeling Language. It is a graphical language for visualizing document models of software system, including structure and design, in a way that meets all of the following requirement, like visualizing. So in this there is a we can how you can visualize. So it is with precise semantics, specifying. So models are precise, unambiguous, and complete to capture all important analysis, design, and implementation decision. So this requirement means specifying requirements will meet. Then constructing models can be directly connected to programming languages, allowing forward and reverse engineering. And another requirement which is required is documenting. So these diagrams capture all pieces of information collected by development team, allowing sharing and communicating the embedded knowledge. So we have some standard, the diagram or UML diagram will consist some standard notation to represent the everything related to the development and everything related to the features of object oriented programming in the form of diagrams. Okay. So this is the diagram. UML diagram is the graphical representation of a set of element, and which will be in the form of connected graph, and connected graph which consists of vertices, which is called things, and arcs, that is relationship. So you can draw diagrams to visualize a system from different perspective. So a diagram is basically projection into a system. Okay, so there are mainly or you can say by using almost these 9 diagram, below diagram, we can make everything which need to represent the model by these following diagrams, like a class diagram, object diagram, use case diagram, sequence diagram, collaboration diagram, state chart diagram, activity diagram, component diagram, and deployment diagram. Even we can add some more diagram, or we can make some additional representations in the systems. Okay, in the open source there are way and tools by which we can represent some other notations and all, but almost everything related to making the model of software or software system we can do by using these 9 diagrams. Okay, so let's see what is class diagram. Class diagram basically, like we know, class is what in the object oriented feature, one of the important feature is what is class. Everything we represent in terms of class, or we can say, so what class consists. So class is basically, we know how we represent the class. So what could be, there could be many data like student roll number, student name, student address and all. So this could be the variable, and there will be some functions. Okay, there will be some functions. So class is basically having data and function. Okay, so how we can represent class in the diagram, so we will see. Okay, so class diagram are, first we see class consists of data and function. These functions are only allowed to access these data. Okay, so to represent in form of diagrams, a rectangle is used. Okay, while we, if we want to represent these things into say diagram, and so this diagram will be called as a class diagram, and class diagram is represented by a rectangle, and we can name like here student, and there we can make 2 sections of data and function. So one way is to represent like this, or even you can simply represent with just a rectangle. Okay, similarly object object diagram you can also represent like this. Okay, so let's see, we will while explaining all these diagram, we will consider some real-time application, and using that application we will try to elaborate the diagram and even the component required to make that diagram. Okay. Okay, so we have in practice a small number of common combination arise which are consistent with the 5 most useful view that comprise the architecture of a software intensive system. For this reason, the UML include 9 such diagrams. Okay, so what is class diagram? So we have seen that class is basically collection of data and functions. Okay, so in class diagram we can write the name of the class, and the data and the functions. Okay, so one way is to represent these all are the class diagram individual, like this is the customer class. Okay, so we can represent this. Okay, so one class is customer, order, special order, normal order. Okay, so here we have taken an example of suppose order system of an application, like suppose customer order something. So how we can make the application of order system of order system. Okay, so we will see the order system of application by exhibiting all the diagram related to make this order system. Okay, so here suppose there could be a class customer. Okay, there could be a class order. So customer will order. Okay, and this order could be, in fact, this could be special order or normal order. So in order to represent the whole things into a class. So we can consider that there could be a class customer, there could be a class order, and even the order could be specialized, or we can say in generalize in terms of special order and normal order. Okay, so one class is having related with another class. So like in ER diagram, even we represent some notations like whether it is partially or fully. Okay, similarly here we can represent one customer could have an order. So cardinality ratio like we represent. So in fact we can give the notation between one class to another by connecting the line, and this line is called a link. Okay, so one class is having related one class linked to the another class by showing a number of associations. Okay, so here we can see that first of all, order and customer are identified as a two element of the system. They have one-to-many relationship, like we can see here. One customer could have an order, like multiple order a customer could give. So in order to represent this thing, how one customer could give, I mean one-to-many combinations, so we could represent here one and n. Okay, and even the order, suppose where the order is special order or normal order, and if this thing is to be represented, so we could use the feature of generalization or specialization by this triangle component ISA. So we can see that special order is a order, normal order is a, so ISA component, that is a triangle component, is required to represent the generalization or specialization relations in a class. Okay. Okay. So here we can see that this one is one-to-many relationship. So by putting these number, this could be represented. And order class is an abstract class, and it has two concrete classes. Okay, special order and normal order. So this is the whole, or individually we can say this is a class diagram, this is a class diagram, this is a class diagram, and the overall class diagram can be shown in the form of like this. So everything is just the representer, how we can represent, because when we represent as a graphical or as a figure, then the analysis and design will be quite simple, okay, and effective in fact. Similarly, for this order processing, customer order processing, we can make object diagram. So the standard way to represent object diagram is just use rectangle, and we can represent like object C colon customer. So this is just the standard way. You use rectangle and the notation for the object and which class it belongs. Okay, like C is the object of customer, so we can write this like we have so many order, so we can make O1, O2, O3 an order. So this is the object and this is the class. So because object is what? Object is a variable of type class. So just to show that, we can use this colon notations. So before colon, this is the object, and after colon, it identify that which class this object belongs. Okay. Similarly, here special order. So S1 is a what? This could be S1 is basically object, and this will be the class. So in object diagram, we can write even the class name. Okay, like this by following column. Okay. Next diagram is a component diagram. So component diagram are used during the implementations. Okay, implementation phase and application. However, it is prepared well in advance to visualize the implementation detail. Implementation means how you write code. Okay, so what are the components? What are the files? What are the library? What are the relationship between the artifacts can be used? How you can represent? So the whole thing could be represented in form of component diagram. Okay, so component diagram are used during the implementation phase and application. It is prepared well in advance to visualize the implementation detail. So before drawing a component diagram, the following artifacts are to be identified clear. What types of file, how many files are going to be used, what are the library and other artifact relevant to the applications, and what are the relation among the artifacts, like this. Okay, so for example, in even order management system, we could have, suppose we are going to implement in Java, so there could be many Java pages or Java files. So say here a customer.java, okay, order.java, even all which need like library, here we can put that. Okay, so this comes under the component diagram. Okay, what are the artifacts and what are the relations between that? If we put all those in some representation like customer, order, okay, then order could be normal order or a special order. So how this you are going to implement? We make the file, or this file suppose needs some another file, then these implementation artifacts you can represent in the component diagram. So component diagram can be used to model the component of a system. It is used to model the database schema. Database schema matlab means design of the database. Okay, and design of the database will include what are the, if we talk about the relational, so design of the database means what are the relation, what are the tables, what are the attributes, what is the relation between the attributes and all that, means primary key, foreign key and all that. So this component diagram can be used to model the database schema. It can be used to model the executable of an application, because we represent all the implementations file in the component diagram. So we can model the executable of application. We can model the system source codes, okay, and all that. Next is deployment diagram. When everything is ready and we want to post over the internet, okay, so components, or you can say nodes, if we not interested, but what are the nodes, what are the requires to do the whole things, this comes under the deployment diagram. Like we would require user, system, modem, internet, server, and so many servers. So all those things could be represented in the deployment diagram. All those nodes, what are the different nodes required to fulfill the applications if it is post over the internet. Okay, so these component could be represented under the deployment diagram. Okay, so component diagram and deployment diagram are closely related. These diagrams are used to describe the component, and deployment diagram shows how they are deployed in hardware. किस तरह से how it is deployed in hardware. This diagram will be useful. Deployment diagram are useful for system engineers, and efficient deployment diagram is very important as it controls the following parameter like performance, scalability, maintainability, and portability. Okay, so before making a deployment diagram, we would require the following artifact. What are the nodes required, like computer system, like user, like server, set of server, and all that. So this is called nodes. And what are the relationship between the nodes? So these artifacts must be must be considered to make the deployment diagram. So above show a simple diagram, deployment diagram to provide an idea of the deployment view of order management system. Here we have shown monitor, modem, caching server, and server, right? So for an order management system, you would require a system, user, modem for internet, and the server which is used. Okay. Now, use case diagram. The use case diagram is what? What are the different cases? Okay. So use case diagram are considered for high level requirement analysis of a system. When the requirement of a system are analyzed, the functionality are captured in use case. Okay. So the functionality is captured in the use cases. Okay. Use case are nothing but the system functionality. Okay. How it's going to function. Okay. So this could be considered under the different use cases written in an organized manner. The second thing which is relevant to use cases are the actors. So in use case diagram, there are two things mainly. One is actor and second one is different use cases. Like if we want to make use case diagram of order management system, so we have order. Okay. So and even the order could be of a special, like normal order. So the actor will be here the customer, and the process like order, special order, and normal order, these could be considered as a use cases. Okay. So customer, order, and order could be extended. Okay. Special or normal order. So these are the different cases, and this consists of one oval symbol for cases and actors for like this. Okay. So this is called use case diagram. Actor can be human user, some internal application, or maybe some external application. Okay. So when we are planning to draw a use case diagram, we should have the following item identified. How we can make the use case diagram? So first, what are the functionality to represent the use case? What are the actors, and what are the relationship among the use case and actors? Next is sequence or collaboration diagram. Okay, it is called interaction diagram. Okay, so collaboration diagram or sequence diagram basically how we can make the flow chart kind of. Okay, and the sequence, and this is the first, then second, then third. If we could represent the processing in terms of sequence, then this is called collaboration or sequence diagram. Like first one is customer, then order, then this order could be special order or normal order. Okay. So see the sequence. Customer send order. Once it confirm whether it is special order or normal order. Okay. So here the function will be the send order function, and there will be confirm just to check. Then so this interaction diagram is represented like this. Okay. We would have to identify the classes and how we can make the sequence. Mean what is the first step? What is the first thing which is going to be invoked? Then second, then third, then fourth, and so on. So if there is a numbering, this is called collaboration. If we do not number, then this comes under the sequence diagram. Okay. So this is just little difference. Actually, sequence and collaboration diagram are the same thing, and this is called interaction diagram. The difference between sequence and collaboration: in collaboration diagram we put the numbering like 1, 2, 3, 4. In sequence diagram there is no specific number. Okay, that's all. Like here we can see the initialization in first step, then second customer, then order. So this is the sequence. First the code initialize. Okay. Customer send order, this will be the first, then order gets confirmed, okay, whether it is special or general order, okay. then dispatch. So this is the 1, 2, 3. So we have specified the numbering. Okay. So this is called collaboration. State diagram, various state. What are the various states? Okay. So these states can be represented with the symbol which is provided in the tools while we make the model. Okay. So these all are various state like idle state, send order request, whether it is the select normal or special order, then confirmation, dispatch order. So these all are the various steps how it's going to, start, then process and all. So just to identify different states, like, okay, activity diagram. So activity diagram for an order management system. Okay. So before drawing activity diagram, we should identify the following fact: activity, association, condition, and constraints. Okay. So these all are the, what are different activity, like customer send an order request. So this could be represented as a activity. Order request system confirm the receipt of the order. Okay. So the, how we identify what are the activities going on. So that could be represented in the activity diagram. And the relationship, the connection between two activity it is called associations. Okay. How it is related, like customer send an order request. So order request confirmed. Okay. So this thing could be represented in the diagram in form of activity diagram. Okay. So basically in UML diagrams, what we do, we represent the different components, all related things in the form of diagram. And for that there are some standard symbol, like for class rectangle, for object diagram, and for all other diagram. So we can make different diagrams just to have efficient and effective analysis. Okay. Thank you.